Okay, so this is the reaction of aldehyde and ketones. So the reaction for carbonyl compound, they have a few. So first of the reaction, we have oxidation reaction, and then in the oxidation reaction, we have a few subtopic. Okay, so maksudnya dalam satu subtopik ada lagi subtopik yang lagi kecil. Okay, untuk oxidation contohnya oxidation of aldehyde and ketone. So kita boleh guna pelbagai oxidation reagent lah. Okay. Second, we have reduction reaction. Reduction reaction pun sama macam oxidation. Kita ada lagi topik-topik kecil dalam reduction reaction. Third, we have nucleophilic addition reaction. Last one, we have iodoform reaction. Okay, so in this part, I'm concentrate of one reaction per part. Okay, means that in this part, I will concentrate on the oxidation part. Okay. Okay, so this is the oxidation reaction. So the oxidation reaction, for the first oxidation reaction, we'll talk about oxidation of aldehyde with KMnO4 and K2Cl2O7. Okay, so aldehyde, if we react with this strong oxidation agent, so what gonna be happen to the aldehyde? So it will form carboxylic acid. For example, we have ethanol react with KMnO4 in acidic and we heat. Okay, so the ethanol will form ethanoic acid. So what gonna be happen? The C double bond here. Okay, CHO means that C double bond O H. So if you react with oxidation agent, so what gonna be happen? The oxygen will be replaced between the carbon and hydrogen. So you will get OH here. So it become ethanoic acid or carboxylic acid. Okay. So second, we have benzaldehyde. So benzaldehyde, same thing. CHO means C double bond OH. React with strong oxidation agent. So it will form benzoic acid. Okay, you just replace the oxygen between the carbon and hydrogen. So for the ketone, okay, for ketone cannot be oxidized, so no reaction for ketones. Okay, why it cannot be oxidized? Because the ketone, okay, so the ketone is bonded to the alkyl group. Okay, so the ketone, they have no hydrogen, because you have to remember, as I told earlier. Okay, so when you do the oxidation agent, so the oxygen will be replaced, will be decreased between the carbon and hydrogen. So because of the carbon do not have any hydrogen, so that's why the ketone cannot be oxidized. Okay, so when aldehyde react with one of the strong oxidation agent, potassium dichromate, okay, because we have few oxidation, a strong oxidation agent, either KMnO4 or dichromate, potassium dichromate, okay. So one of the strong oxidation agent, potassium dichromate, okay, they have a color. So the color of the potassium dichromate is orange. So when aldehyde react with potassium dichromate, form a carboxylic acid, so the color of the potassium dichromate will be changed into a green. Because why it changed? Because you form from Cr to the Cr3 plus. Okay, so from orange to the green. Okay, next oxidation is oxidation reaction of aldehyde with Tollern reagent, okay, or we call as silver mirror test. Okay, so Tollern reagent, what is a Tollern reagent? Tollern reagent is ammoniacal silver nitrate. Okay, this is the formula AgNH3 2 plus. Okay, so we call as a Tollern reagent. So the Tollern reagent is a mild oxidation agent. Okay, mild oxidation agent. So what gonna be happen when aldehyde is warm with the Tollern reagent? Okay, when aldehyde is warm with the Tollern reagent, So the colorless complex ion, okay, before it been warm, the tolerant reagents, the color for the tolerant reagent is colorless, okay. So when it's warm with the aldehyde, the color of the AgNH3 2 plus will reduce, okay, to gray metallic silver, okay. So we can see here now we have colorless, okay. This is the beginning of the reaction, okay. After the reaction with the aldehyde, it become gray metallic silver, okay. So and then it will form, the precipitate will form a silver mirror, okay. So you can look at the wall of the test tube, you can see they have a silver mirror here, okay. That's why tolerant reagent known as silver mirror test, okay. So the equation, so this is the equation. We have aldehyde react with tolerant reagent, okay, in a base. So what gonna be happen, it will form CH3COO negative from ion plus with Ag, okay, Ag. So this Ag give gray metallic silver, okay, plus with NH4 positive plus with NH3. So this is the equation to, so we have the simplified equation, okay. This is the real equation, so we just remember the simpler equation. So you have aldehyde react with Ag plus. So Ag plus is the tolerant reagent in a water H2O. So what gonna be happen? The aldehyde will be oxidized, will form carboxylic acid here, plus with Ag. Okay, from Ag plus it will be oxidized to Ag. So the Ag become gray metallic silver plus with H plus. Okay, so this is the general equation. Okay, so tolerance test is used to distinguish aldehyde from ketone. So ketone do not react with tolerant reagent, only aldehyde. Okay, any oxidation reaction, only aldehyde will react with the oxidation agent. Okay, next, number 3, we go to the reaction of aldehyde with Fehling solution. Okay, Fehling solution. So standard solution we use copper. Okay. If the tolerant reagent we use Ag. For the failing solution we use copper 2 complex ion. So we use copper 2 sulfate solution react with the potassium titrate in NaOH. Okay. So what gonna be happen? Before the reaction, CO2 plus is in a blue color, so valent solution in the blue color. So after react with the aldehyde, so aldehyde will form a carboxylic acid. So the Cu will become Cu2O, okay, will become copper 1 oxide, copper 1 oxide. From Cu2 plus, it will become Cu plus, okay, it will become Cu plus. So it becomes copper 1 oxide. So the color from blue, it will transform to the brick red precipitate, or we call as reddish brown. So the Fehling solution can be distinguished, okay, between first, of course, the aldehyde and the ketone, because the ketone does not react with any oxidation reaction. Okay, so the ketone does not react with Fehling solution. Okay. Second, aliphatic aldehyde and benzaldehyde. Only aliphatic aldehyde can react with Fehling, but benzaldehyde cannot react with Fehling. So this is two uh, distinguish that can be made by using the Fehling solution. Okay, as summary, the oxidation, okay, for aldehyde, okay, they have three type of oxidation. First, we use the strong oxidation agent, KMnO4 or Cr2O7, or we can use tolerant reagent, mild oxidation agent, tolerant reagent. Okay, so tolerant reagent, what going to be happen in aldehyde? It will form a silver mirror wall. Okay, it will form a silver mirror wall. And third is Fehling solution. So Fehling solution, when react with the aldehyde, it will form from blue color to the reddish brown solution. Okay, for ketone, it cannot be oxidized, so it means it cannot be react with either camphor or tolerant reagent or Fehling solution. Okay, so that is the summary for oxidation reaction.